We were working on number 6 from the 2004 AP Calculus AB free response. It was part B, or Form B, I should say. And we were given this graph, and in part A, we were supposed to find the integral from 0 to 1 of x to the n dx. That's just a simple power rule, and we're going to do, because it's a definite integral, the fundamental theorem part 2. So with the power rule, we do x to the n plus 1 over n plus 1. And we're going to evaluate that between 0 and 1. When you plug in 1 for x, you get 1 over n plus 1. When you plug in 0, you get 0 over n plus 1, which is 0. So the answer for that part A is simply 1 over n plus 1. I'm going to go ahead and erase that, and then let's talk about part B. In part B, we have to find the area of the triangular region labeled T, which is this guy right here. And as you know, that the area of a triangle is 1/2 base times height. For us, the height equals 1 because that's the y value of that point over there. And really what we need to find is this base right here, that piece. So here's the deal. Line L has an equation, y minus 1 equals m times x minus 1, where m is the slope of line L. And we can actually find that slope by taking the derivative of function y equals x to the n, because that L is defined as the tangent at that point 1, 1. So the derivative of x to the n is n x to the n minus 1. And when you evaluate that at the point 1, we get 1. We get n times 1 to the n minus 1, which is going to be n. So the slope is n. So the equation for line L turns out to be y minus 1 equals n times x minus 1. Now, I really need to find out the coordinates of this point right here where L crosses the x-axis. And that's going to happen when y equals 0. So if I just plug in a 0 here, I can solve for x. And you'll see that what's going to happen is I'm going to divide by n, and that is x minus 1, and then add 1 to both sides, and you get x equals 1 minus 1 over n. Now I'm going to have to make some space here, so while I chit-chat with you, I'm going to erase this part over here. Now that we know x is 1 minus 1 over n, I just need to figure out what that distance is there right here on the base of that triangle. If that x-coordinate is 1 minus 1 over n, then that red distance there must be 1 minus 1 minus 1 over n. And when you simplify that, you get that base to be 1 over n. And so the area of the triangle is now 1/2 times 1 over n times 1, because this height here is 1. So the area is 1 over n. And, I'm sorry, 1 over 2n, which is what we were supposed to verify. So 1 over 2n is in fact the area. Now we've got to talk about part C. I'm just pausing so you can take it all in. I'm going to start erasing, and then we'll do part C. And in part C, the first thing we want is an expression for the area labeled S, which is this green stuff over in here, right? Well, as it turns out, S is just going to be the original area that we found in part A, which is the area under the entire x to the n curve, which was 1 over n plus 1, minus the t area, the triangle that we just found, which was 1 over 2n. And then they want us to determine the value of n that maximizes this area. And from calculus, you know that the way we maximize something is we take the derivative. All right? So S prime of this thing is going to be negative 1 over n plus 1 squared, just taking the derivative using the power rule and use substitution. But and then the other one here is going to be plus 1 over 2n squared. To solve this and find the maximum, we need critical points, so we're going to set it equal to 0. And then we can turn this into a proportion. I got to practice my 2's on this thing. You can see we're doing a little algebra and a proportion here that we can make. Ooh, that's 2n squared, by the way. We can turn this into 2n squared equals n plus 1 squared. Take the square root of both sides. We get the square root of 2 times n equals n plus 1. And then what we're going to do is we're going to solve for n. And what we get when we do that is n square root of 2 n squared root of 2 minus n equals 1. Factor out an n, and we get the square root of 2 minus 1 equals 1. I got to erase some stuff over here. This screen is not big enough for what I like to do, I guess. And then I'm going to divide by square root of 2 minus 1. Which gives me n equals 1 divided by the square root of 2 minus 1. If you want to rationalize that denominator, we can multiply by the conjugate, which is the square root of 2 plus 1, and square root of 2 plus 1. And you'll see on the bottom here, we're going to get 2 minus 1, which is 1. That's a difference of squares. And on the top, we're going to get 1 plus the square root of 2. I'm just switching that around so there's no question about whether or not that 1 is square rooted. So there we go. That is the value of n that will maximize the area S, the region S there that I colored over there in green. Hopefully this helped, and we'll do more coming up soon. See ya.